The problem of low priority bottlenecks. The problem of low priority tasks preventing you from doing high priority tasks and dealing with the seeming irrationality. Let's say you really need to do something because otherwise negative consequences will follow, so you kinda have to do it. But at the same time, we assume you are an absolute rational human being, doing only rational stuff like categorizing all your incoming tasks, deciding how important they are and how urgent. You could use something like the Eisenhower matrix or another function to calculate the priority of a single task. The next step is very simple. Doing the task with the highest priority value, and that's already all we have to know about life. Step 1, put all the incoming tasks into your inbox. Step 2, calculate priority. Step 3, work accordingly. But sometimes there is this problem, a problem which is seemingly irrational. Let's say a task is a pretty low priority, as low as basically to be eliminated. But you somehow cannot eliminate it, therefore there will always be tasks with higher priorities, which often extend infinitely. Let's assume you don't have a million yet. Then the highest priority thing theoretically should be do something to earn money. The problem now is, if you still don't have the million yet, the task of earning money extends seemingly infinitely until you reach the goal of 1 million. Which, by the way, probably isn't enough for your retirement anyway. Also, you could get hit by a car any day, your health insurance could be broke any day. Hint, the current health systems are pretty much doomed in terms of existing in the future due to average population age rising, therefore cost increasing and not enough young folks to pay for the old ones. And also the simple fact health demands are rising independently due to everyone having a right to be treated with today's standards, and standards are rising. Enough said about the health system. About the healthcare system. This leaves you with the basic problem of these tasks completely blocking everything else, since for each and every second, the smallest time increment we take a look at, you theoretically would calculate your priorities again, then act again. And since sleeping for the next second probably can be postponed for another second, you should do the task with the highest priority in the second, which hint will always be prio numero uno. Of course, this problem in reality theoretically is solved by your priority function, because with every second you don't sleep, the calculated priority should rise up to the point where the plot of the priority of sleep, the graph of the priority of sleep over time tops the priority value of work, and therefore the right decision given by your priority function shouldn't be keep calm and keep working, but sleep. Therefore you sleep until your priority function's output spits out another task as the highest priority task, and then it's time to do that one again. Here again the original problem. When plotted over time, a task's priority value never exceeds the top task's priority value. It never gets done. And the second constraint, it cannot be deleted. Then you are basically frozen. Some would even use the words beginning with the letter F, because these tasks will accumulate and accumulate theoretically infinitely. And also the amount is not capped. Let's say you somehow got a new router, and you or someone else wanted to replace the old one. But the old one is completely fine in every aspect. It's just that the other one is already there and should be installed. Then you are in big trouble. Also, there often are external variables that make it into your personal life but not into your priority function. Therefore, installing the new router will never be something that should be done, because there will always, at any given moment, be a task with higher priority, like writing blog posts, for example, in order to increase the probability of your blog success due to more words, more content, and so on. Of course, this is just a completely random example, but still, not to say it is intractable, a mathematician's way of saying not solvable, but still this task will just stick to your list until you finally have to admit, Houston, we have a problem. Another example, you eat clean. You also don't throw away food. You know about psychology and the simple fact that whenever you are in an environment with unhealthy food, your chances of eating unhealthy rise again. It's not that you cannot control it with enough willpower, but given the fact the amount of willpower is fixed, and it doesn't make sense to allocate more willpower to controlling your food intake, because this would mean reducing your effectiveness due to your checking of less or lower priority tasks. In reality, a function with the main inputs, number of tasks, and the priority of each. It just doesn't make sense to allocate your willpower differently, and of course, it could make sense if the variables and their factors change, but that's not really the point here. The point instead is this: now someone gives you unhealthy food as a present, then you are basically out of options, because first, you eat healthily, or healthy. Second, increasing the amount of unhealthy food in your environment isn't tolerable. Because of probability, willpower, and so on. Third, you don't throw away food. Fourth, you cannot get rid of the food otherwise because there are other constraints preventing you from doing that. Also intractable and traceable. Unless you use something like Lagrangian relaxation, which basically is this. You simply ask yourself, are my constraints really constraints, or is there some leeway I can use to solve my intractable problem of scheduling tasks? Not to sound too important, but a problem like this actually prevented a space probe from sending more data, because a lower priority task never got done, and this led to the task completely blocking the processing capabilities of the space probe. The priority algorithm seemingly was fine. Until it wasn't anymore, because it just kept ignoring the low priority task until it broke. Like the internet these days, either by a girl dancing on TikTok or Google taking a nap, and therefore a huge chunk of the internet being no longer accessible is the thing you want to avoid. So the solution, not to say your basic life problems are now solved, but this is the theoretical solution. Freeze your priority function and do stuff that doesn't have a high priority, which is a contradiction, because your priority function should always spit out the task with the highest priority. That's the reason we set it up in the first place. In reality, it's different, and there is no contradiction, but the real problem is and will be if we don't make any changes to little variables. See, when we set up our priority function, we simply couldn't foresee an event like the one just described. Therefore, the function doesn't account for these scenarios. Therefore, the seeming contradiction. The solution again is the Lagrangian relaxation, relaxing your constraints, in other words, re-evaluating the function of your function and counting in these rare scenarios. But still, the problem will exist because unpredictable events will always pop up, not even at a certain rate, because the nature of an unpredictable event is it's unpredictable. It's unpredictability. So in summary, whenever there is a problem with your brain's processing power, simply re-evaluate your priorities and design a new, even more complex priority function using your brain's now seriously limited processing power. Good luck with that.